We've looked at the theory behind the intersection of circles within a 2D geometric space, and we've looked at the 5 different possibilities that can occur. So they were when the two circles don't touch each other at all, when they touch each other once and they're both external to each other, when they touch each other at 2 different points so they cut twice, when they touch once but one's enclosed within inside the other, and the final scenario was when they're both enclosed within each other but there's no point of contact between them. And we looked at the different properties that they have to satisfy for either one of those. What I'm going to do here is I'm going to set you a couple of questions. I want you to pause the video, have a crack at them, and then come back and check your answers with the work solutions I'll present. Here you go. So the first one is looking at 2 circles that touch at a single point and how you can show it. The second one, I want you to find the distance, the smallest distance between 2 circles when these are the equations that they're given. Now, the key thing to look at is it's between the circles, not the centres. Bear that in mind when you're doing your math. And the final one is 3 circles in a space, all with a collinear set of centre points. There's the equation of the 2 smaller ones. I want the equation of the bigger one. So pause the video and have a crack at these 3 questions. So the first question was, if I've got these 2 circles with these equations given here, so the first equation is this one, second is this, I want to prove they touch at a single point. Now remember, when we talked about touching at a single point, there were 2 possibilities. One was this scenario where we had the 2 of them touching externally, and the other one was when we had one circle contained within the other and they were touching at one point there. Now both of these had a special property. If we take D to be the distance between the 2 centres, for this scenario with them externally, if I added the radius of both circles, it would be equal to this. However, for this one here where one's enclosed within the other, my distance would be equal to the bigger radius, take away the smaller radius. If I could prove either of these 2, then I'm laughing and I've got my scenario there. So let's take this circle up here as being circle 1, this one here as being circle 2, get our centres and our radii and see what we can get. So this one up here, looking at the various properties of the general equation of a circle, I can say that 2g is equal to 4 and 2f is equal to 16. So from that, I can say g is equal to 2 and f is equal to 8. I can then look and say, right, I know my centre point from that. My centre point is at -2, -8 for that circle. This one here, I can do the same thing. Say my 2g, this time it's equal to -8, and my 2f is equal to 4. So I then know that g is equal to -4 and f is equal to 2. So my centre for this one, let's call it C2, is at 4, -2. So we'll make this one C1. What I then do is I calculate my radius for both of them. So my R1 is equal to the square root, remember this is the g squared plus f squared minus c formula. So for this one, my g is given by 2, my f is given by 8, and I get my c from this part of the formula here. So it's then equal to 2 squared plus 8 squared, take away -60. 2 squared is 4, 8 squared is 64, so that's 68, minus 60, minus becomes a plus. So it's then 68 plus 60, 128. Now root of 128, that can be simplified down to 8 root 2. Looking at this one, I can do my second radius now, my R2, and it's the same formula, just different values. There's my g, there's my f, and for this one, my c comes in from here. So in this case, I want the square root of -4 squared plus 2 squared, take away 12. So -4 squared is 16, 2 squared is 4, so that's 16 plus 4, which is 20, take away 12, it's the square root of 8. Square root of 8, that can be written as 2 root 2. So what I now need to do is calculate my distance between the centres, and I can see which one of these 2 I'm going to satisfy. So my distance d, in this case, is equal to the square root, remember it's x1 minus x2 all squared, plus y1 minus y2 all squared. So in this case, x is 4 and -2, so it's going to be 4 take away -2 squared, plus the y's, -2 take away -8 squared. So 4 minus -2 is 6. 6 squared is 36. I've then got -2 plus -8, so that's -2 plus 8, which is 6. And again, 6 squared is 36. Add them together and I get the square root of 72. Square root of 72 can be written as 6 root 2. Now, if I was to do R1 plus R2, add the 2 radii, I'd get 10 root 2. Doesn't work. But if I did R1, 8 root 2, take away the 2 root 2, R1 minus R2, that gives me 6 root 2, which is equal to the distance d, which means that it satisfies this condition here, and my two circles do indeed touch at one point, but I can also safely say they're enclosed within each other. So the bigger circle has the wee circle inside it. The second question, find the smallest distance between the circles given by this equation here and this one here. Now, key thing to remember is the distance between the circles, not the centres. So what that means is I've got two circles here, I've got a centre there and a centre there. You can imagine the distance there between them, but what this means is it's the distance between the circles, which is this gap here. Now to do that, it's a couple of simple steps. Distance between the two centres, my 2 radii, and if I take the 2 radii off the distance, I know what gap's left, and that's the answer I'm after. So again, let's take this one as being circle 1, this one here as being circle 2, and calculate the properties we need. So circle 1, my centre C1, I can get by remembering again that 2g is equal to 20 and 2f is equal to 16, which means that g is equal to 10 and f is equal to 8. Putting this together, negative g, negative f, I get negative 10, negative 8 for my centre of my first circle. Second one here, I can simply read it off. C2, it's just these values here, 8 and 16. Then I do my radius, R1 and R2. So in this case, R1 equals the square root, again same formula, 10 squared plus 8 squared, take away c, and c in this case is 64. So that's equal to the square root of 100 plus 64 minus 64, well that's equal to the square root of 100, which you should all know by now, is 10. Radius of this one comes from the fact that this part here is equal to r squared. So I know that r2 squared is equal to 64, so r2 has to equal the square root of 64, which is 8. So now I've got the 2 radii, I just need to get the distance between my two centres. So my distance, d, is equal to the square root of negative 10 minus 8, all squared, plus negative 8 minus 16, all squared. So in that case, that's the square root of negative 18 squared plus negative 24 squared. So negative 18 squared, that's 324. So it's the square root of 324 plus negative 24 squared, 576. That's equal to the square root of 900, which is equal to 30. So what I can then say, let's imagine I call this distance here capital D. I know then that capital D equals my distance, take away R1, and then take away R2. So I subtract the 2 radii from it, and I know the gap that's left. So in this case, D equals 30, take away 10, take away 8. So the smallest distance between my two circles is D is equal to 12. That's the gap that's in here, and that's the bit that I'm after. The final question was this one here, with the 3 circles touching externally. The centres are all collinear, so they're all on that line. So you can imagine my third circle, the big one, centres there. 2 smaller circles have these equations. Find the equation of the larger circle. So the first thing I'm going to do is I'm going to calculate the key properties of the 2 smaller circles, their centres and radii, and then see how I can look at using this to get my other part. So let's stick with this one here being C1 and this circle here being C2. So for C1, I can read off the centre as negative 2, 0, and I know that R1 squared is equal to 9. Again, this bit here is just R squared with the format it's written in. So I then know that R1 is equal to 3. So I've got the key parts for my first circle. I then use this bit to get my second circle. So let's imagine I look at C2. I've got 2g equals negative 20, and I've got 2f is equal to negative 32. So if 2g is equal to negative 20, g is equal to negative 10, and f is equal to negative 16. What that means is I can say my centre C2 is located at 10, 16. I can then get my radius R2 using the square root of g squared plus f squared minus c formula. So in this case, it's the square root of negative 10 squared plus negative 16 squared. Take away the c, which is given by 347. So doing that, I get the square root negative 10 squared is 100s, plus square root of negative 16 squared is 256. Take away 347. 100 plus 256, take away 347, ends up giving me the square root of 9, which I can tell you is 3. So I know the two radii here are the same, so I know that this bit here is the same as this bit here. So if I calculate the full distance here from there to there, and I take those off, I'm going to get the diameter of my big circle. So there's my first key point that I need to do. I also know that the distance from there to there then is the same as the distance from there to there. So what I could imagine is treating this like two right-angled triangles. I can use these bits of information to then get to this center point here. But let's look at the diameter first. I know the distance between the two centers is going to be given by the square root of negative 2 take away 10 squared plus 0 take away 16 squared. So all I need to do is do both of these parts, take the square root, and I'm done. So square root of 12 squared plus square root of 16 squared. Well, 12 squared is 144, 16 squared is 256. That gives me the square root of 400, which is equal to 20. So my distance between my two centres is 20. To get the diameter d, I simply do the 20, take away 3, take away 3, and I get 14. That way my radius, I can simply say, is 7. Now that I've got that, I need to find the centre. Well, my centre, which we call C3, is halfway between the two centres of my two smaller circles. Because we know this is the same and this is the same, we know exactly where we need to be. So we just need to find the centre of these two circles, and we're sorted. So my centre C3 is given by halfway between these two. So I've got x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So in this case, that's going to be given by x1 plus x2, so negative 2 plus 10 over 2, comma 0 plus 16 over 2. So negative 2 plus 10 gives me 8, 8 over 2 gives me 4, and then 0 plus 16, 16, half of that gives me 8. So there you go, that's the centre of the big circle. Now I just need to plug it all together and get my equation of the larger circle. So in this case, it's going to be x take away 4 squared plus y minus 8 squared equals r squared, which in this case is 7 squared, which is 49. So there you go, we've put together all the key bits of information, calculating distance between 2 points, using centres of points, diameters, equations of circles in both forms that we're after, and we've found that centre and the radius to then give us the answer to this problem in the equation of our circle. It's all about thinking about how all these different properties relate to each other and how we can use them to calculate other various components and parts of the system we're working with.